So in section 3.2, we looked at two different kinds of compound statements. Primarily, we mentioned a couple others, but the two we've primarily looked at so far are conjunctions and disjunctions. And today we're going to look at a third one, and that is the conditional. We've mentioned conditional, but we haven't talked very much about it. So conditionals are compound statements that use the connective if-then. I've shown you that they use that arrow as the symbol between them, and we read them as P implies Q. You can say if P then Q as well, but P implies Q is how we sort of read the symbols. Antecedent or premise, either of those words, are referring to the if part, P. And then the consequent or the conclusion is referring to the then part, the Q. So the tricky thing about if-then statements is that they don't always occur in an if-then order. This is one of those caveats of English that we just get to deal with, and from a mathematical perspective, it's not the friendliest thing to sort of encounter, but we can work with it. So let me show you what happens when we have statements that are not sort of in the proper order, or they don't show up with the if and the then where we would expect. So the directions say to rewrite each statement using the if-then connective, rearrange words or add words as necessary. So if you look at the first one, it says it must be alive if it is breathing. The if is not at the beginning. Do you see it though? It's in the middle. So when we're rewriting a statement with an if-then connective, we start with where the if is, and that moves to the front of the sentence. So we're going to start now by saying if it is breathing. And then we go back to the part that we skipped over, and that's my then part. Then it must be alive. Is that all right? Okay, so wherever if is, it just moves to the beginning of the sentence. And then we have things like number 2, where there's just not an if at all. But if it's an if-then statement, it's just not written. So it says, a shopaholic has no self-control. All right? So there's several things that we could do. If you were looking at these inside of my math lab, they're probably going to be done as a multiple choice. So they're not going to have you putting in those extra words. They're going to supply the extra words, and you're going to decide which one is properly done. So what we write down right now might not be exactly the same from me to Jordan to Quentin. I mean, we could all write down something slightly different, and it would actually be okay with the extra words we had in. So I'm going to write one of them down. So we start with an if, obviously. And I'm going to use he. If he is a shopaholic, then he has no control. Does that make sense? But I don't have to use the word he. I could have used the word she. You could have used the phrase a person. You could have used the phrase the word they. There's lots of things that could have come into place right here where I just chose to use the word he. Okay? So there's nothing special about the pronoun or the descriptive, of the person or whatever that we're talking about. Does that make sense? We'll see some more of these in a different fashion in a little bit. Just like we did with conjunctions and disjunctions, we want to be able to go back and forth between the words and the symbols. So our next couple of examples are practice doing just that. So our statements are, she has a ferret for a pet. They're very stinky pets, by the way, if you've never been around a ferret. And P represents he trains dogs, okay? And M represents they raise alpacas. Random statements. It doesn't matter what the statements are, okay? My math lab's going to give you some other kind of random statements, and they're going to put them together. And it wants you to express the compound statement, P implies tilde M, in words. So we always start out with if, because there's the arrow. The arrow tells us the if will be our first word. And then what does the statement P represent in words? He trains dogs. So if he trains dogs, that's the first part. And we're sort of moving from left to right. We come to the arrow part. We put the word then. So there's that if-then connective showing up. And then when you need to do the negation of M. We talked about negations last time, okay? We talked about the fact that they're not always super straightforward. This one is the very simple statement. The M statement is they raise alpacas. So what would the negation of that be? They do not raise alpacas. If you don't know what an alpaca is, an alpaca is kind of like a llama. So, there's actually a farm nearby our house that has alpacas on it. Yeah. Okay, is that right? So we're taking symbols, we're writing them in words. And then we're going to do the reverse of that. We're going to take words and write them in symbols. Same words are, S is she has a ferret for a pet, P is he trains dogs, and M is they raise alpacas. It says, if he does not train dogs, so here's my if, and here's my then. And the statement that starts out is right here, if he does not train dogs. So, what will I write at the beginning of my conditional symbols? Yep, it'll be squiggly because it says not, right? And which symbol is it we're using for the training dog symbol? That one was P. Okay, and then the word then comes next, so then I have an arrow. Okay? Okay, everybody good with those pieces so far? Tilde P, arrow. All right, after that, we actually have a couple of more statements, and we have another connective. So you can actually have another connective showing up as well, which we do here. We have the or connective. So these are the pieces that go with the then. So we're going to put them in parentheses because all of this is following the then. If this, then these things. Okay, so we're going to put the parentheses. The first statement says, she has a ferret for a pet. What letter is that? That was S. Now we ran into the word or. Do you remember the symbol for the word or?
Is it a V?
It is a V. Good job. Okay, so V for or, upside down V for and. And the last one says they raise alpacas. What's that one? M. Whoops. M. Now, this is an example of one where my math lab generally has you put these symbols in. Right? It can deal with that just fine because there's not language involved, right? It's just the symbols. So they're probably going to have you put those symbols in, and if it flips back to you and says something's wrong, check the connectives, check the arrows, look and see if you missed some parentheses, things like that. Graydon.
On math lab, do we do the parentheses as well?
You would need the parentheses on that, yes.
Okay.
Yeah, if they're not in there, it would tell you not to, or if you put them when it's not necessary, it's going to error out on that too and tell you it's wrong. Yeah, so just pay attention to it.
How come on this one you put parentheses, but on 3 there wasn't no parentheses?
Well, first on 3, there's only 2 statements.
Okay, so if there's 3.
If there's 3 statements, you might have parentheses depending on the language and how it's worded. This one we did because everything after the then came together as a single compound statement. Okay? All right, let's take a look at the next one. So we did truth tables last time for a lot of statements, but basically for the if then or for the connective statements that were the and the or. Today we're going to do a truth table for a conditional, and this one is a little bit harder to see sometimes how it works. So let's start with how we know truth tables always start. I have two statements I'm comparing. The statements are P and Q. And you can tell me exactly what column P should say. What should it say?
True.
True.
False.
Right. And then what should column Q say?
False, true, true.
Nope.
True, false.
Nope.
True,
False,
false, true, false.
Say it again a little bit louder, Eva.
True, false, true, false.
True, false, true, false. Okay, so there's no guessing involved. It's always going to be like this.
I wasn't guessing.
Always, always. Yeah. But maybe you haven't done your homework yet to practice. So this will always be the same. The P's and the Q's, when there's just two statements, will always be true, true, false, false, and then they oscillate. The statement that we're trying to create the truth table for is the conditional statement. P implies Q. So I'm going to be a little bit careful this time since I messed up my P and Q initially last time. And we'll make sure we get this written correctly. So P is going to be the statement, I am a mom. And Q is going to be the statement, I am a woman. Okay. So these are my two statements. We're going to try to think of the people that we thought of last time. I don't know if I'll use the same people or not. I'm not sure if they'll fit, but we'll see. So if anybody comes in, though, and they say this statement with these connecting, right? So if I'm a mom, then I'm a woman. Is that true? If you're a mom, you're a woman. Yes. Don't go 21st centurying me, okay? This is not up for discussion. If I'm a mom, I'm a woman, period. Okay? You can be a dad in there too, and that's fine, but that's not what we decided my statements were. I started with if I'm a mom, then I'm a woman. Yes?
Can't you always, like, for this example, can't you, like, determine the first one just because P and Q
Are both true.
Yeah.
They do end up working out that way in all of our truth tables. It's all the other three that we don't get for free. Yeah, but you're correct. All of our truth tables, the and statements, the or statements, and the if-then statements, if they've got two trues, it's true. You're right. All right, the next one, if the person comes in and says, if I'm a mom, now what I'm going to do is I'm going to actually change this to a false statement, which is the negation of what I've got. So if someone comes in and they say, if I am a mom, then I am not a woman, you would say, no, that doesn't work, right? That's not true. So that's a false statement. Okay, so those two are the ones that sort of concretely seem quite reasonable moving forward. The last two are kind of funny. And they're funny because they actually start out with statements that are false. And if the person comes in and you don't know who the person is, right? Maybe even they're standing out the doorway, maybe they send a text message to you. And they say, I am not a mom. If I am not a mom, then I am a woman or then I'm a man. The statement could be true either way, correct? Yeah, right? Most of you in this class, I presume, do not have children yet, correct? Most of you are not moms. So we have some in here who are not moms and are men, and we have some in here who are not moms and are women. So our default case for both of these is that these statements are both true. And they're both true because we err on the side of believing that somebody's telling us the truth when there's not a reason to know for sure that they're not. Right? Them not being a mom does not determine whether they're a woman or a man. We have absolutely no further information at that point to be able to say, you're lying. Right? We don't. So we assume that they're telling the truth. So you will always have your notes with you as you're doing these things. The truth tables always work out like this, but this is the discussion and the reason as to the why. Okay? So like Graydon pointed out, the true truths are always true in all three of the truth tables we've discussed. All the other ones oscillate a little bit, right? And statements mean both statements have to be true for it to be true, and everything else is false. Or statements mean at least one of them's true, and then it's true. And then with an if-then statement, it's the weird one. If it's true, true, it's true. But also if the statement starts out false, my last two lines, it's automatically a true statement. Okay? So we're going to do some of the same things that we did in the last section where we're finding truth values and we're creating truth tables for some statements that we were given. So anytime you see the statement that says truth value, It means that this is a one-line truth table because they're telling you some of the pieces of information. They're telling you in this one that P and R are false and Q is true. Does that green show up? Oh, very good. I'll change that color. Okay, so those are the pieces of information that we have from the get-go. We don't have all, of the 8 possibilities. We have a given specific possibility. So our statement on letter or number 5 only has 2 letters, R and P. So I don't necessarily have to put Q into my table. If you do, it's fine, but it's not going to actually come into any of the argument part of it. So I'm going to do a statement, a truth table, and I'm going to do R first, and the reason I am is because it comes first in the conditional, and it's easier to read it from left to right. So I'm just going to go in order. That's probably not going to help me. I was thinking it would, but I'm going to have my tilde R next, and so now they're out of order, but we'll be okay. We'll be okay. All right, so we have R, we have P, and we're going to have a tilde R because there is a tilde R in the statement that we're working with, right? Okay, so given the information that I highlighted in the yellow, what is R?
False.
False. What is P?
False.
False. Okay, so those are given pieces of information. So if R is false, then the negation of R is true. Okay. And then our last column in our truth table will be the tilde R implies P, the whole statement that I'm looking at. And so this is my beginning point, sort of like my arrow, and it's going back here. So this statement is a true implies false. If you go back up to the truth table, was that statement true or false?
False.
That's the false statement. It's the second line. A true implies false is a false statement. So this one would be false, and the overall truth value is that it is false. Now the next one has more going on because it's got 3 symbols. Great.
Why was it false again?
Because it's referring back to this line, true, false. Because it says tilde R, which is true, and then it says P, which is false. So you have to identify where you are in the truth table arrangement. We're on the second row of the truth table. A true implies false statement is the one of the 4 that are false. Okay. Yes, back up.
Is there any reason that we have to write out the entire truth table if we could just fill in?
So it's a good question. It depends on what they're doing inside of my math lab. They may have you fill all the pieces in along the way. Or they may just say, find the truth value, and in which case you could try to reason through it, and we can hope that your reasoning through it without sort of the supporting evidence will work. So one of the things that has become I've become aware of from my math lab as well, is that a lot of times when they have this one, like let's say they did this one, and they didn't have you write out the truth table, just said decide if it's true or false, right? So if you say that it's true, which would be an incorrect statement, it's not going to give you a second attempt at that problem. It's going to give you a brand new problem, and you're going to have to completely start over. So you still get 5 attempts. You just don't get 5 attempts to decide if something's true or false, because once you say it's true, then it's automatically must have been that it should have been false if it was wrong. Does that make sense? So it depends on what you're given inside of my math lab, but the reason it came up is because students were like, it says I have only 1 attempt. Well, they did at that particular problem, but if they get that one wrong, then it just gives them a brand new problem. So I don't know if anybody's experienced that in here. Nobody in here has messaged me about that yet, but it will happen eventually. All right, our next one has 3 statements. The statements are P, Q, and R, so I'll put them just in order. P, Q, R. Let's look at some of the things we need. So if I'm moving from left to right, I can put the tilde P next. If you want to start inside the parenthesis, you can put the Q and R next. I kind of like moving from left to right on the conditionals, so I'm going to put my tilde P next. And then I'm going to put the Q and R statement after that. And I need one more column. Do you know what it's going to be? The whole thing. And you can write the whole thing out, like just rewrite this as the column header if you want. Or you can write it like I was doing last time, where I'm identifying the rows that I'm going to be using. And my last one is going to be row 1 implies row 2. If you don't like that, just give it the column header name of what the actual statement is. That's fine. Okay. P, true or false?
False.
False. Q,
True.
R.
False.
Okay, so that's the parts they gave us. So what's the negation of P?
True.
That's true. And statement. We haven't done an and statement today. An and statement has us go back and look at Q and R. And when is an and statement true?
Yes.
When they're both true. So is this one true or false?
False.
This one's false. Okay? So this one's a false statement. And then now for the column that I'm on here at the end, I'm looking at column tilde P, which I've labeled 1, and column Q and R, which I've labeled 2. It is a true implies false statement. Is that statement true or is that statement false?
False.
That's false. That's still line 2 of my truth table above. So this would be another false conclusion. Okay, any questions on those so far? Okay, so sometimes when we're working with truth tables, the last column will all have T's at the very end. Everything will say T, 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 it will have all T's. And when that happens, it's actually a statement that's called a tautology. So a tautology is a statement that is true no matter what the truth values are. That is, the final column of the truth table is all T's. So tautologies are one of those things that if my math lab asks you to do it, it's going to ask you first to create a truth table. And then looking at your truth table, it's going to ask you, is it a tautology? Okay? So it forces your work to have to match, but not to match and both be incorrect. For example, if all of your work shows all T's in the last column, but you've made a mistake, and therefore you call it a tautology because you got all T's, my math lab's not going to give you credit for calling it a tautology because it's not set up to do that. Okay? It's one of those things that I would go in afterwards. I would look at partial credit for quizzes and exams to make sure that you understand the connection between those two things. But my math lab is just not going to be able to do that on your homework. Okay? So we're going to create truth tables for the next couple of them with these directions to construct the truth table and then identify if it's tautology. So we'll either say yes it is or we'll say no that it isn't. All right, so on this one, how many statements do I have? 2 statements, because there's only 2 letters, right? I know they're showing up more than one time, but there's only 2 letters. Everybody good? Okay, and what was that?
P,
P and Q, yes. So we're going to do our column headers with P and Q.
That one's pretty.
I know. All right. There is a tilde involved. It happens to be inside the parenthesis as well. So I do need the negation of P as a column header because it shows up inside of the statement I'm working on. And then if I take a look further, sort of inside this, the entire statement that's inside the parentheses includes the tilde P and the arrow and the Q. So that would be my next column header, which we'll call column 1 because it starts to get a little bit messy with too many column headers. Whoops. Here we go. Okay. The last piece, where it says the arrow and the Q, is already in my truth table. So I don't need another column for Q. I mean, if you wanted to put it in, you could. It's not going to hurt anything. But there's no need for it. You already have a column for Q. So this column number 1 that I listed before is going to be the premise, right, the beginning part of an if-then statement that will end in column Q, which is earlier in my truth table. So I'm going to have to be going sort of backwards again. Right? I'm going to have to be looking from this column backwards. So if it bothers you to look from this column backwards, you can just rewrite column Q. It's not going to hurt anything. Okay. Column P always looks like what?
T.
There we go. True, true, false, false. How does column Q always look?
True, false, true, false.
Thank you. True, false, true, false. Always the same. All right, so after we have those 2 columns written in, The tilde P, or the negation of P column, means I'm going to go back to P and I'm going to do everything backwards. So what is the negation P column going to look like?
False, false, true, true.
Yes, false, false, true, true. And then I'm actually going to be going from tilde P back to Q. So this is the direction that I'm looking as I'm making my statements. So this is a statement right here on row 1 that starts out false and ends in true. And what do we know about statements that start out false with conditionals? They're always true. So these first 2 lines actually start out false with the tilde P, so they are automatically true. The third line starts out true and it ends in true. And like Graydon mentioned, all those statements actually become true. And the last one starts out true and it ends in false, which leaves me with false. That's my one false way to get an implication, right? I get an implication in one way being false. That's it. And then we're going to take column 1, the one we just created, and we're going to go backward to column Q. So I'm going to re-highlight it, and we're going backwards the same way. So on the first row, I have true implies true. That is true. On the second row, I have true implies false.
False.
That's a false statement. On the third row, I have true implies true.
True, true.
True. And the last one, I have false implies false.
True.
That's true. Okay, so looking at that last column, is this a tautology? No, because it's not all true statements. This is not a tautology. Yeah.
When do you do two tables like this compared to the ones with only one line, like the last question?
Yeah, because this says truth table, construct a truth table, and this one over here said define the truth value. So finding a truth value like this one, they already told us P, Q, and R, or whatever the letters are, and they told us whether they were true or false. That's why I've automatically been able to put them in, because they told it to me right there. P and R are false, Q is true. But if you look at the direction set for this one, they don't tell you what P, Q, and R are. So they just tell you to create a truth table, and you have to create all possible options. Yeah. It's the directions and how they describe what they're asking for. Yep.
On number 7,
Yes.
On the 4th row, how again were you able to tell that if it's false to true, that's true?
Because when we created our truth table over there, if any statement starts out false, it's automatically a true statement. Okay, so that when is a conditional true? Well, it's true implies true, or it's false implies anything else. So true implies true or true statements, and false implies true or false implies false are true statements as well. So that's why that happened on that one. Okay, we're going to do one that's bigger. This one's going to have how many statements?
3.
3 statements. So we talked about last time, how many rows does that mean we're going to have? 3 statements, but how many rows?
8. Isn't it 8? 8.
It's 8, yeah. We haven't done very many of them, but it is 8. So we're going to create a truth table. And our truth table, I'm going to just go in order alphabetically. That's what you'll tend to see them doing inside of my math lab as well. P, Q, R. And let's go ahead and create the rest of the column headers right now. Okay, so I've got the P and the Q and the R. I usually look and I see, do I need any tildes? And I do. Which tilde do I need? Q. I need tilde Q. So I list any of the individual statements that have a negation to them, just individual statements. And then I look and I see what I've got inside of parentheses somewhere. So inside of the parentheses, I actually have a compound statement. Do you remember if this one's an and or an or? It's an and statement. Very good. Okay. And once I write a statement like that, I'm going to give it a column header named 1 for reference for myself. And then, so I've got all of this now written. What I don't have is the whole thing. So my last column is going to be R implies 1. Those are the column headers that I'm going to be using. Okay, so a lot of you remembered for 2 statement truth tables, the true-false values in the first 2 columns. What do I do when I have 8 rows and I have a P, Q, and R? Do you remember?
Have you figured out their true, false first?
Well, the first 3 columns are always identical. We talked about it last time.
Is it true, false, true?
There's going to be 1 column that is, but not the first one.
It's R.
It is R that's going to have the true, false to it. Okay.
Like 4 truths and then 4 false?
Excellent. Good job, Marcus. So we have 4 truths.
Oh, that's what you was talking about.
That's what I'm talking about. We need to fill it in. 4 falses. I didn't make it quite long enough. Whoops. There's nothing else to do but to keep moving forward, right? What about the Q column? What is it?
Opposite, right?
It's not opposite. They're never opposite. The opposites come from negations.
True, false,
Alternating.
It's not alternating.
true, true, false.
That's the one, yeah. So this one is the one that goes true, true, false, false, true, true, false, false. And then finally, the one everybody wants to keep telling me about is the alternating one with the row R, T's and F's. And they do. They alternate. Okay. Took a little bit more work than I thought it was going to take. You guys good now? Excellent. We do have a negation column now, a negation of Q. So we're going to go back to column Q. Column Q is the one that went 2 T's, 2 F's, 2 T's, 2 F's. So if I'm negating that, what am I going to do?
The opposite.
That's going to be the opposite. Yeah. So it'll be 2 F's, 2 T's, 2 F's, 2 T's. And then the P and tilde Q. So here's P, and here's tilde Q, highlighted in yellow now. When is an and statement true? When they're both true. So we're just going to go line by line. The first row, it says true, false, so that would be false. The second row says true, false, so it's false again. The third row says true, true. That's true. And the fourth row says true, true. And that's true. So remember, and statements, they both need to say true. How about the last 4 rows? P is false in all of them, right? So if P is false, it were a conditional, it would be true, but this is an and statement. So we've got falses. I've got some falses and trues, but an and statement is only true when both statements are true. And in the last 4 rows, P's false. So I don't have a true statement. It will be false in the last 4 rows. All right. Then we're going to do column R with column 1. And this one's the implication. Okay? Not an and now, but an implication. So implications are true when it's true, true. And implications are true when it starts out false. So row by row, the first row says true, false. That would be false. The second row says false, false. That's true. It started out false, so I get an automatically true statement. The third row is true, true. That's true. The fourth row is false, true. That's true. The fifth row, where I am, is true, false. That's false. Good. My letters are a little bit all off on there, so it'd be better if you have lined paper. The next one, the sixth row, is false, false, which is true. It's the weird one that feels weird because it starts out false, but it's okay. The seventh one is true, false, which is false. And the last one is false, false, which is true. Is this a tautology? No. I promise there are some that are. I just didn't have examples on these cases that were. This is not a tautology. What are you looking for again? What's a tautology? All true in the final column. Exactly. Okay, so that's all for the truth tables part today. We're actually going to take a look at a couple other things and then we'll finish it up. Yes?
I'm still a little confused on the Q part.
Okay.
So, I guess, how do you know it's true, true, false, false, not like the other ones?
How did I know, like, do you mean how did I know to set it up like this with these pieces? Those three rows or three columns?
No. On the Q column, instead of it being like the
This
last
one?
ones, like true, false.
Because R is going to be that way.
Right, but how do you know that?
Okay, so we did that in class period last time, okay? And we explored how we're trying to list all possible combinations. So the way that we get all possible combinations is that we create statements where there's truth in all of them, there's false in some different pieces along the way. And so we're trying to create something that we can always do in the exact same way every single time. So this arrangement of these three columns gives me every possible true-false combination of three statements. The order is done the way that it is so that it's easy to remember and you don't miss any of them. There's actually nothing very special about the fact that they're in this order. The thing that makes it special is that it makes it easy to catch all of them and not accidentally duplicate a row and forget a different row. Okay? So when we do the truth table that has only two statements, there's just not as many combinations of two statements that can be trues and falses. So the only options are the true, true, false, false, and then they alternate. This is an expanded one because it has three statements. So we have 4 trues and then 4 falses, and then we oscillate them in pairs, and then we oscillate them individually, and that captures all options.
So because there's 3 in this one, that's why you had to do
Exactly.
true, false, false? Okay.
Yes, it's because there's 3 individually different statements. Yeah. All right, so we're going to talk about what is the negation of P implies Q. So the negation of P implies Q is actually a statement that's an and statement. So what this is saying is that if I did the negation like this, right, De Morgan's law kind of stuff, right? When we did it with ands and ors, we sort of did this distributing thing through, and it just changed all the pieces. It doesn't work like that for this one because it's an arrow. So what is the negation? Well, the negation on this one is actually that P happens and Q doesn't. That's the negation, right? If it's cold, I wear a coat. So what's the negation of that? Well, it's cold and I didn't wear a coat. That's all this is saying, right? The if part happened, but the then part didn't follow through. If I do my homework, then I get to watch TV. I did my homework and then I sassed my mom and then I still didn't get to watch TV, right? It's my kids. Right? So this is the negation. It keeps the first statement the same, and it creates an and statement with the second statement being false. So the negation of it. So we're going to do this with some language ones now. So it says to write the negation of the statement. It says, if Ella reaches that note, she will shatter the glass. So the two statements are Ella reaches that note, and she will shatter the glass. The word then isn't actually written in here, but if it helps you to see it, you can put it there. So when I do the negation, I keep the first part the same for an implication. I just don't use the word if. It's just going to use the statement. Ella reaches that note. And then the if then turns into the word and. And then I negate the second statement. And what?
She will not.
She will not, or she did not, depending on your present, past tense kind of stuff. So I'll put will or did not shatter the glass. Is that all right? So the negation of a implication is an and statement where we just negate the second piece. We actually have an equivalent way of writing a conditional statement as an or statement. So if I have P arrow Q, this is exactly the same as having, make sure I get them in the right order, tilde P or Q. So if you think about our truth tables, this kind of makes sense. Or statements in a truth table end up with lots of statements at the end that are true, right? Remember, you got, like with just a two-statement truth table, you end up with one false statement at the very end and 3 truths. That's the same thing that happens with an implication. You end up with one false statement and you have all the truths. And in particular, you end up with a statement that's true, true, like Grady mentioned before. If it starts out true and the other one's true, then we're good to go. And you get the ones that start out false as well. So this next one, or that's what this is actually saying. Tilde P would mean that the first statement's false, right? It means that P is false. P is false, Q, tilde P is true. Tilde P is true. Or the resulting statement is true. And we would actually have the same one. So we're going to take a statement now and write it as an or statement. It's in if-then form. Again, it doesn't have the word then in it. Sorry. Okay. It doesn't have the word then in it, so if that bothers you, just put it in there. The two statements are she doesn't and he will, which are kind of short and sweet. So instead of writing an if-then, we're just going to write the first statement as a negation. So the first statement says she doesn't. So what's the negation of she doesn't?
She does.
She does. And then I won't have a implication anymore. I'll have the word or. All right, this becomes an or statement. And then I leave the he will the same. She does or he will. This is the same statement. It is equivalent. It doesn't have all the connotations that we mean, right? But it actually would create the exact same truth table. If you were to create a truth table for this and a truth table for this, the very last columns would have the same T's and F's in the same combination. Great.
Where did you have to make that she does not?
It already is she does not. She
Well,
doesn't means she does not.
But when you rewrite it,
Right, when we're not rewriting it, we're doing the negation. This says that I'm doing the negation of P. So the negation of does not is does.